Hi everyone. In this chapter we will be studying linear functions. In this lesson we will be looking at the standard and general forms of the equation of a linear function.
Alright, well for the last few lessons we've been looking at the equations of lines, and well, we started with looking at slope and then we started looking at a couple of equations of the lines here. And so you're familiar with the slope y-intercept form, which is y equals mx plus b. And just recently we looked at the point slope form, which is y minus y1 is equal to slope times x minus x1. Now I want to introduce you to just a couple of more equations here. There's kind of a break that happens right here. These guys right here are good for graphing. Okay, if you want to know what these relationships look like, these are really, really convenient forms to put the equation of a linear function in, because I can see right now the pieces that I need to plot this very, very quickly. These two forms here, the general form and the standard form, they are more important to us in an algebraic context. Okay? Now, we're not going to have really a lot of time in this particular course to explore this, but you would see later on here how, as we move forward here, there's going to be a whole group of objects that you're going to study in general form. And it's kind of weird to explain this, but there's a form, what we call degenerates, that look like this. Okay, I know that sounds that word maybe sounds awkward there, but there are well, the objects that I'm referring to here, like circles and ellipses and whatnot here, there's degenerate forms of those that are going to become lines, and they're going to look in this form here. This one right here, we're actually going to explore a little bit more in this particular course when we start looking at systems of equations. Okay, when we start solving systems of equations, you're going to find that often we're going to use the standard form to solve them. Now, the key properties of the general and standard forms here are that A, B, and C, okay, these things right here, first of all, they're called parameters. Actually, so are the M and the B in the other equations here, but these are called parameters. What we want here is we don't want any fractions here. We want all of these things to be integers, if at all possible here. Okay, that's exactly where we go. And we want the A value here to be positive. Order becomes important here. We want to write these things in this general or standard form here, starting with X, then B, and then whether we put the C on the left side or the right side of the equal sign, that kind of depends on what they're asking for here. But this is the form that it's got to be in to be, or this is what it's got to look like, I should say, to be in either general form or standard form. Now we're going to take a little bit of time, do some questions where we go back and forth. All right, so we're going to write each one of these things in general form, meaning we're going to have it equal to 0. Now, first of all, I want to get rid of fractions. Okay, none of the coefficients are fractions, so we're good. But what I want to do here is I want this thing to be equal to 0. So I'm going to do the easiest thing I can. I'm going to bring the y over to the right-hand side. Now, the reason I'm bringing it over to the right-hand side is because I can see that the coefficient of x is already positive here, and I want that. So I'm going to subtract y from both sides. So this will be 3x minus y minus 1, and that's going to equal 0. Now, when you look up at the general form, okay, you're going to notice that it's ax plus by plus c equals 0. Now, if you liked having that equal 0 on the right there, then what you can recognize here is that if 0 is equal to 3x minus y minus 1, then it is equally true that 3x minus y minus 1 is equal to 0. You can just simply write it on the other side, and that's totally fine. In our second question here, first thing I want to do is remove the fractions here. Now I notice I've got a negative 3/5 here. Okay, I'm working with an equation, so there's a little something that I can do here. I'm going to multiply every term in this equation by the common denominator. Well, in this case, there is only the one denominator. I'm going to multiply everything by 5. Now, the reason why I'm going to do that is because, very specifically, if you multiply negative 3/5 by 5, okay, if you put a 5 in the numerator, now remember, when I multiply by 5, I'm not distributing it to numerator and denominator. It only goes to the numerator. Then those 5s will cancel, and I'll get rid of that fraction. So that's why I'm choosing to multiply by 5. Now, but everything gets multiplied by 5. So 5 times y is going to be 5y. Negative 3/5 times 5. I've put a 5 up here. Those 5's cancel. I'll be left with negative 3x. And then 5 times negative 2 will be negative 10. Now, multiplying by 5 really doesn't change the relationship here, but it does allow me to get rid of the fraction here. Now, I would like to put this in general form, meaning the coefficient of the x, I would like that to be positive. Okay? So I'm going to bring everything over to the left-hand side just by adding it. The 5y term was already positive. I'll bring the 10 over, make that equal to 0. And in this case here, notice that everything is on the left-hand side equal to 0 on the right. That's exactly the way I want that to look. So that's good. You can leave it like that. All right, notice this one over here is already in point-slope form. I do want to get rid of the fractions here, but before I do that, I got to kind of work my way into what's going on here. I'm going to distribute this 2 through. So I'll get y plus 3/5. I'll deal with that in a bit. Is going to equal, well, 2x. And now if I multiply 2 by negative 3/2, remember this is like 2 over 1, so that 2 goes to the numerator, and then the 2 will cancel with the 2 in the denominator here. So really I'm just going to be left with minus 3. So after distributing that slope through, actually I don't have any fractions on the right-hand side, but I do have one on the left. So I'm going to multiply everything through by that denominator. Everything, remember. So the 5 is going to distribute to the y first. So 5y plus, okay, well if I multiply 5 by 3/5, if you want to think of it this way, that becomes 15/5, and 15 divided by 5 is 3. 5 times 2x is 10x. 5 times negative 3 is negative 15. Every term has to get that 5 distributed to it. Now, I've got rid of the fractions. I'm going to bring everything over to whichever side is going to allow me to keep the x positive. And right now the x is positive on the right-hand side. So I'm going to subtract 5y from both sides. And then I'm going to subtract 3 from both sides. And actually, because of that negative 15 over here, when I subtract 3, I'll get negative 18. So there's my answer. There's nothing wrong with writing it like that, but if you want to have the equal 0 on the other side here, that's okay. We just have to rewrite this as 10x minus 5y minus 18 is equal to 0. If it's equal to 0 on the left, it'll equal 0 on the right, okay? That doesn't really matter what order you write that in. Equal to 0 is equal to 0. Now our next question right here, a little bit more difficult because there isn't a single denominator there. There are 2, and I'm not going to be able to get rid of those simply here. So I'm going to multiply through by the common denominator, which in this case is going to be 6, the least common multiple of those denominators. So when I multiply 6 by y, I will get 6y. And now 6 times negative 3/2. 6 times negative 3/2. Now let's just think about that. This is like 6 over 1. So the 1 times the 2 is just going to give me 2 in the denominator. That's not the hard part. But I'm going to get 6 times negative 3 in the numerator. Well, 6 times negative 3 is negative 18. Let's just think about that. Negative 18 and a 2 in the denominator. Well, that's negative 9. And then over here, 6 times, and I can put that negative with the 1 here. 6 times negative 1, so negative 6 over 3 times 1, which is 3. Well, negative 6 divided by 3, negative 2. So by multiplying by 6, by multiplying by that least common multiple between those denominators, I've gotten rid of the fractions. Now what I want to do is set everything up so that it's equal to 0, and my x coordinate, or the x term here, the term with the independent variable, is positive. Now that's going to involve me moving these terms over to the other side. So I'm going to add 9x to both sides. 6y is already positive. Add 2 to both sides. And I get 9x plus 6y plus 2 is equal to 0. All right, let's take a look at this one right here. Okay, well this is nice because there are no fractions here, which is good. All I have to do is bring everything over to whichever side of the equation allows me to have that coefficient of the x positive, and that's going to mean bringing it over to the left-hand side. So I'll add 5x to both sides. Now the 2y didn't have to move, it stays. I'll subtract that 1 from both sides, equal to 0. Okay, That was easy. That was a nice one. And then finally, we've got another one that's in point-slope form. And again, before I get rid of the fractions, I'm going to distribute that slope through, just to make this a little bit easier to look at. So y minus 1 is going to equal, okay, well that's going to become negative 3 halves x. And then negative 3 halves times 1/6. Okay, well I tell you what, we'll do this in 2 steps here. So negative 3 halves, that's going to be negative 3 times 1, so negative 3, 2 times 6 is 12. Okay, now before I multiply through by something to simplify this, or to get rid of the fractions I should say, I'm going to reduce this because I know that 3/12, that can be written a little simpler. That's like negative 1/4. And now I want to get rid of the fractions, but now the number that I have to multiply through, the least common multiple of 2 and 4, well, the nice thing about that is that's just 4. And when I distribute that through, I will get 4y minus 4. Okay, now watch this. This is like 4 over 1. 4 times negative 3 is negative 12. 1 times 2 is 2. So negative 12 divided by 2, negative 6. 4 times 1 over negative 1 times over 4, I should say. So it's going to become negative 4 over 4, negative 1. All right, it took me a couple steps here, but I got rid of the fractions. Now I need to bring everything over to whichever side is going to allow the coefficient of x to be positive. Well, it's negative here, so I'm going to add it, bring it over here. So 6x plus 4y, didn't have to change the y. And then I'll add 1 to both sides. Negative 4 plus 1 is going to be negative 3, is equal to 0. And so that's the equation of that line in general form. All right, now this question is asking us to find the x and y intercepts of each equation, and we're given them in general form. Actually, this is very easy to do. You just have to remember that when we're talking about the x-intercept, what we imply is that the y-coordinate is equal to 0. So let's just think about what's going on here. If the y-coordinate goes to 0, that term disappears, and so we've got 2x plus 8 equals 0. So let's just take a look at that. 2x plus 8 is equal to 0. Because remember, 4 times 0 is 0. If we let the y-coordinate go to 0, it goes away. And I know some people have a hard time with that, but that's all that you had to understand here is 4 times 0 is 0, and like 2x plus 0 is 2x. Bring the 8 over, so 2x equals negative 8. And then divide by 2, and we'll get that x is equal to negative 4. So our x-intercept here is going to be negative 4. The y-intercept, you do the exact same thing, except this time we're going to make the x-coordinate equal to 0, and so we're left with 4y plus 8 is equal to 0. Bring the the 8 over, so we get 4y equals negative 8. So divide both sides, and we get y is equal to negative 2. So our x-intercept here is negative 4, our y-intercept here is negative 2. So maybe we'd write it like this. Okay, negative 2. Simply because x equals negative 4 isn't actually an x-intercept, this is a line. Okay, to say x equals negative 4 is to give a vertical line, y equals negative 2 is to give a horizontal line. But here we'll just give the numeric values there. Over here we'll do a very similar sort of thing for our x-intercept. Again, we're going to let the y-coordinate go to 0. Now, bear in mind that that means we've got negative 5 times 0 is 0. And so this is actually going to become 4x minus 20 is equal to 0. Bring the 20 over. And so we get x is equal to 5 for our x-intercept. So maybe we'll write that over here. For our y-intercept, we're going to let x go to 0, which gives us negative 5y minus 20 is equal to 0. So negative 5y, bring the 20 over, it becomes positive, and then divide, so y is equal to negative 4. So our y-intercept here is negative 4. That's all you have to do. Okay, so this question says determine the value of each unknown with the given information. So here we've got an equation partially done in general form here. We know that it passes through the point 4, negative 5. Bear in mind what you're being told here. Okay, this is x, this is y. These are the x and the y coordinates of a point that's supposed to be on this line. Now that x and that y correspond to this x and this y, meaning that we can make the substitution 2 times 4 plus b times negative 5 plus 7 is equal to 0. So what do we got here? We've got 8 minus 5b plus 7 is equal to 0. I don't know, maybe bring the 5b over. 8 plus 7 is 15. 5b, and then we divide and we'll get that b is equal to 3. There we go. The issue that we got to get people past here is realizing that when I give you the point, I am giving you those specific values of the variables right there, the x and the y. Let's take a look at this next one here. Ax plus 5y minus 6 equals 0, and again passing to the point negative 3, 2 there again are my x and my y coordinates here. So this is going to be a times negative 3 plus 5 times 2 minus 6 is equal to 0. So what we got here? We got negative 3a plus 10 minus 6 equals 0. And maybe I bring the 3a term over again. But 10 minus 6 is 4 equals 3a. And then we would divide by the 3 to get that a is 4/3. Okay. Now, that's actually kind of an interesting result here, to be honest with you, because in that form here we would not expect the a to be a fraction. Okay, but that's okay. This is just picked as an example to kind of have us work through this. Once you plug that in there, you'd multiply by 3 just to get rid of that denominator. All right, so the question says here, write the equation in standard form. So ax plus by equals c, and the only difference between this and general form is bringing the c over, of a line that has the same slope as this line and passing through this point here. Now, okay, well, first of all, we have to figure out what the slope of this line is. So I'm going to isolate the y here. So 4y, I'm going to bring the 24 over, is going to be 3x minus 24. And then I'll divide every term by 4 to get 3/4 x minus 6. So our slope here is 3/4. So I want the equation of a line in standard form that has a slope of 3/4 and passes through the point, negative 2, 2. Now, remember that in standard form, this is not a form that's easily graphable just by looking at it here. So what I'm going to do is when I am given this information, I'm going to create the form of an equation that is easily graphable first. And you know what, I'm quite lazy. I'm going to put this in point slope form. So in point slope form, I'm going to get y minus 2 is equal to the slope. Sorry, I don't know why I threw that down there. This is going to be 3/4. And then x minus negative 2, so x plus 2. Okay, now I want to put this into standard form. Okay, so once I've got it in point slope form, or depending on the circumstance, maybe slope intercept form, first thing I might do is multiply this thing through. Okay, so y minus 2 is going to equal 3/4 x plus, okay, now if you multiply 3/4 by 2, remember this is like multiplying by 2 over 1, so it's going to become 6 over 4. 6 over 4, each of those has a common factor of 2, so this will end up being 3 over 2. I would like to now get rid of the fractions, because remember that's an important rule here. I want a, b, and c, okay, to have no denominators of them. I don't want any fractions there. So I'm going to multiply every term here by the least common multiple of the denominators, which in this case is just going to be 4. And I'll get 4y minus 8. All right, 4 times 3/4. Okay, 4 over 1 times 3/4, the 4s will cancel. I'll be left with 3x. And then 4 times 3 is going to be 12 over 1 times 2, so 4 times 3/2 will just be 6. Now, to get this into standard form, I want the x term and the y term on the same side, but I want the x term to be positive. So notice that the x term is positive right here. So I'll bring the 4y over, and I'll bring this 6 over to this side. So negative 8 minus 6 will be negative 14, will be 3x minus 4y. All right, good. Now that is technically in standard form. Now, if you don't like the way that looks, bear in mind with equality, because it's an inequality, if it's written this way, it's just the same as making this 3x minus 4y equals negative 14. I mean, if negative 14 is equal to 3x minus 4y, then 3x minus 4y is equal to negative 14. You can write it in this way if you'd like as well. But there we go, standard form. All right, this next question is very similar to the one that we just did. It says, write the equation of the line in general form. And so we give you the general form there. That is parallel to this line right here. and passes through the point 1, negative 6. Okay, so once again, I have to come up with this equation here, and it's not likely going to be directly into general form. I'm probably going to have to play around with this a little bit. So first of all, I'm going to take that equation right there, that 2x minus y plus 4 equals 0. So I want a line that has a slope parallel to this. So the first thing I'm going to do is get y by itself. I'll divide through by the negative, so I get it entirely by itself here. Okay? And I can see now that my slope here is going to be 2. So the line that I'm looking for is going to have a slope of 2. And it passes through the point 1, negative 6. Well, the easiest thing for me to do is to just immediately put this into point slope form. So y minus negative 6, y plus 6 is equal to 2, x minus 1. That's just the absolute easiest thing for me to do. Then I can switch it into general form. Now to do that, I will distribute the 2 through, so 2x minus 2 when I distribute the x through. And remember how general form works. I don't want there to be any fractions, and there aren't any. And I want everything to be on one side, but I want it set up so that the coefficient of the x is positive. Well, it is positive on this side right here, so let's just move these two terms over. So 0 will equal 2x minus y, and then I'll subtract 6 from both sides, and negative 2 minus 6 is negative 8. And so there you go. Now, that is really in general form here. However, I know that some of you are going to be happier if we write it like this, with the equals 0 on the other side. There's no problem with that. That's all you have to do. Okay, next question here is again kind of on that same theme here. Write the equation of the line in general form, again, but this time we want it to be perpendicular to the given line and passing through an x-intercept of 9 here. Now let's just really quickly here bear in mind that this is going to be the point 9 comma 0. That's what I've given you when I give you the x-intercept here. Now, take a look at this. I need my line to be perpendicular to this one, meaning that I got to figure out what the slope of this line is. And so I have to put this into slope-intercept form. So I'm going to bring those two terms over. So negative 3x plus 6. Trying to get the y by itself. Now I'll divide by 2. So y is equal to negative 3 halves x plus 3. So the slope of this line here is negative 3 over 2. The slope of the line that I want, which is perpendicular to this one, is going to be positive, first of all. And then I'm going to make the reciprocal of that. So the slope that I'm looking for has got to be 2/3. I also know that it's got to go through the point 9, 0. So I'm just going to put this directly into point slope form. So y minus 0 is going to equal 2/3 times x minus 9. Now, to put this into general form, I need to expand this out, get rid of the fractions here. Now, y minus 0 is just y. 2/3 of x will be 2/3 x minus, now okay, when I multiply this through by 9, remember this is like 9 over 1, so 2 times 9 is 18, 3 times 1 is 3, so 18 over 3 is just going to be 6. 2/3 of negative 9 will give us the negative 6. Now, I need to get rid of the denominator. And so there is only the one denominator here, so I'm just going to multiply every term by that denominator to get 3y. When I multiply 3 by 2/3, and I hope you're getting more and more comfortable with this, 3 times 2/3, this is the same as 3 over 1 times 2/3, so 3 times 2 is 6 over 3 is going to be 2. And then 3 times negative 6 is negative 18. To put this into general form, I want everything on one side. I want the coefficient of the x to be positive. So I'll bring the 3y over. So 0 is equal to 2x minus 3y minus 18. And if you don't particularly like that, you can bring everything over and write this as 2x minus 3y minus 18 equals 0. And there you go. Okay, well, I hope you anticipated this next question coming up here because it has been part of the last few lessons here, this some reference to horizontal and vertical lines here. But in the previous couple lessons here, we kind of showed how they didn't really fall into those patterns, those previous patterns. Well, now we've got a nice tool for working with this. Write the equation in general form, here we go, of the line that passes through the point 7,5. So you kind of have to bear this in mind here. We're going through the point 7,5 here, parallel to the x-axis. Okay, if a line is parallel to the x-axis, that means it's a horizontal line. Okay, now just think about how that works here. We've already done this repeatedly here. If it's parallel to the x-axis, that means the equation is going to be y is equal to some constant k. Okay, notice that x doesn't even play a role in this, and it hasn't. Okay, we've done this several times, it hasn't done that. Plug the y coordinate in, we get 5 is equal to k. So there we go, y is equal to 5. That's the equation of the line. We've seen this before. Now, but to put this into general form, I want everything over on one side equal to 0. So what I would do here is make this y minus 5 is equal to 0. That's the equation now of a horizontal line in general form. Now, next question, perpendicular to the x-axis. Okay, well, perpendicular to the x-axis is a vertical line. We know that a vertical line is going to have the equation x is equal to k. Because remember, a vertical line, all of the x coordinates are going to have exactly the same coordinate here, okay? So in this particular case here, if we plug in the value of x that we've got from the point, we get 7 is equal to k. So therefore, the line is going to be x is equal to 7. And now, to put this into that general form, I bring this over so it's equal to 0, and I get x minus 7 is equal to 0. And this is the equation of a vertical line in general form. And like this form, when we start talking about vertical and horizontal lines, whoops, wrong way. Vertical and horizontal lines here, this form of the equation is way more useful for those kind of lines. Okay, so for this question here, we're going to write the equation of a line in general form. Now, there's a bit of a wording issue here. If it has the same x-intercept as this line, and is perpendicular to this line right here, well, okay, same x-intercept as this line here. Now, to get the x-intercept, we make the y-coordinate equal to 0. So 3x minus 5 times 0 is equal to 15. So 3x is going to equal 15. Okay, so x is equal to 5, meaning that the point that we've got here is the point 5, 0. Okay, so there's our point. Now, we need a slope. Perpendicular to this line right here. Well, okay, to get the perpendicular, or to get the slope of that, first of all, I got to isolate the y here, put this into slope-intercept form. And I'll do that by bringing those two terms over, isolating the 4y. Now divide by 4, and we'll get negative 5 quarters x plus 1/2. So the slope here is negative 5 quarters. I want the slope perpendicular to that. So I'm going to change the sign. So mine will be positive. And then I'll reciprocate that. So the slope here is 4/5. Now, again, I'm not going to go directly into general form. What I'm going to do is I'm going to go to point slope form. So my line here is going to be y, now minus 0. But y minus 0 is just y. Is equal to the slope 4/5 times x minus 5. Good. Now, okay, in previous questions, what I did when I had something like this is I expanded that out and then I multiplied through to get rid of the denominator. But truth be told, I can do that right now if I wanted to. There is only the one denominator, so I can multiply by 5 to make this 5y equals. Now, before I even distribute that through, I will multiply this coefficient by 5. This is 5 over 1, so this becomes 20 over 5. Or 4 times x minus 5, and now I'll distribute that through. So 5y is equal to 4x minus 20. Okay, so I could have distributed that through first and then multiplied this 5 by everything, or I could just multiply that coefficient through by 5 before I distribute it through. Either way, I get the same result here. Now I want to bring everything over to the side that leaves the term with the x positive, so that's going to be bringing the 5y over, so 4x minus 5y minus 20, and that's equal to 0. And again, I can rewrite that as 4x minus 5y minus 20 equals 0, if you'd rather have that equal 0 on the other side. All right, now this next question is kind of a little blast from the past here before we go on and let you work on an assignment here. A line through the points 5 comma n and 1 comma negative 2 is parallel to this line right here. We've got to figure out what the value of n is. Well, if it's parallel to this line right here, I got to figure out what that slope is because it's going to have the same slope. So 3x plus 2y minus 1 is equal to 0. I got to get that 2y by itself, put that into slope-intercept form so that I can figure out what the slope is. I got to isolate the y. So I bring over the 3x and the negative 1, and I'll divide by 2, and I get that my slope here is negative 3/2. Okay, so the slope of the line segment going through those 2 points is negative 3/2. So now I've got these 2 points here. I'll just use the slope formula. I know that the slope will equal negative 2 minus n over 1 minus 5. Okay? Now, I'll do a little bit of simplifying here. This is negative 3 over 2 is equal to negative 2 minus n over, it's going to be negative 4. And now remember what we've done in the past here. When I've got fraction equal to fraction, okay, remember I can think cross-multiplying essentially, that if I take this numerator and multiply it by the denominator on the other side, I get the same result as multiplying the numerator and denominator here. And so now this is going to become positive 12 is equal to 2 times negative, whoops, whoa, I don't know why I wrote it like that. Negative 2 minus n. Now, divide both sides by 2, because we got to get the n by itself here. So when I divide both sides by 2, 12 divided by 2 is 6. That leaves me with negative 2 minus n. I want to get the n by itself, so add 2 to both sides. So 8 is equal to negative n, and then divide by the negative. And we get that the value of n is negative 8. Okay. You need to be comfortable with that slope formula. And hopefully this process here is something that you're comfortable with and can move forward with and use on your own.